Hey guys, my name is Frank and this is the Python programming video log. Today I'm going to do a watch me write video on how to make a bouncing ball program using pure HTML5 and JavaScript. I'm literally going to write this entire program from start to finish, explaining the code as I go, so stay tuned to see how it's done. Of course, leave your questions in the comment section and be sure to give this video a like if you learned something. Alright, so let's get to coding. So the first thing I need to do is define my doc type, and that's just going to be lowercase HTML. Find HTML tag, close it, HTML, and then we're going to do the head and the body tag. So head and the head tag, body and the body tag. And this is just going to set up a basic structure for our HTML document. You always need a head and a body tag. Then the next thing I'm going to do is I'm going to come in here and I'm going to add a title. Title is just going to be ball bounce, and in the browser window you can already see that I have that title in the window because I've already tried to do this once and failed. So this is take like 2 or 3 here. So the title from the last project is already in there, but when I refresh, this title is going to be the tab title right there. I'm also going to add a meta tag, meta, with the name of viewport and the content of width equals device width, and that is going to keep my resolution the same across all devices, whether they're a phone or a desktop computer or a tablet or whatever. I'm also going to come in here and I'm going to add a style tag, and I'm going to use that to just style some of the elements on my page, because right now I have stuff like margin and padding that I really don't want on the page. If I come in here and I refresh the browser window and I use the developer tools to check out the HTML tag and the body tag, as you can see, they're really tiny, and they're going to need to cover the entire screen. So what I'm going to do is I'm actually not going to worry about them so much, but I'm going to use the asterisk selector to make the margin and padding of the HTML and body elements 0, because I don't want any padding on those elements. So now when I refresh, my body tag and my HTML tag don't have any margin or padding on them at all. It doesn't matter what browser they're in. It's going to remove margin and padding, and that's going to allow me to just fill the entire screen with this canvas element that I'm creating in the body tag right now. So what I'm going to do is I'm going to take this canvas element, I'm going to select it in the CSS by saying canvas, and I'm going to make the height of the canvas 100%, the position of the canvas fixed, and the width of the canvas 100%. So now if I leave this code out, what I'm going to get is just a default canvas size. So the canvas default size is 300 by 150 pixels. So that's just going to be a tiny canvas. But when I add back in my CSS style for the canvas element, what's going to happen is it's going to fill the entire browser window. So when I highlight my canvas now, it fills in the entire browser window, and that's great. The only problem with this is height 100% and width 100% is skewing that original 300 by 150 pixels to be the full size of the screen. So any image that you draw inside your canvas is going to be skewed this way, but we're going to take care of that resizing of the canvas inside of the game loop. And now that we have everything set up in the HTML and CSS, we can actually get into the script tag. So here we go, script. Actually, I'm going to put the MIME type on there, type equals text or JavaScript, and script. I'm going to come in here and get a handle on the drawing context of our canvas and actually give it a background color. So let's go var context equals document.query selector canvas.get context 2D, and that's going to get the 2D canvas rendering context from the canvas element that I've added to the browser. So to show that, I'm just going to say alert context, and that should show us that our code is running smoothly, and we have, I don't know why I put the string there. It should just be the variable. There we go. My bad. Refresh that. It says canvas rendering context 2D, so we have that canvas rendering context. We got it from the HTML. We can access it inside of our JavaScript. So now I'm going to say context dot fill style equals, like my go-to green color here. It's going to make it a nice mid green or dark green. And I'm going to say context dot fill rect, and 100, 100. So that's going to draw a 100 by 100 width and height rectangle of green inside of my canvas. But as you can see, it's skewed because the canvas element's original size is 300 width by 150 height, and it's skewed over the entire screen. So this would be closer to the original aspect ratio. But until we actually resize our canvas to really fit in pixels, pixel per pixel fit of this inner dimension of the browser window, we're going to have a skewed image. So just wanted to show you guys that. But next, I'm going to create a game loop. And it's really simple to create a game loop with request animation frame. All you do is create a function. I'm going to call mine loop. So I have function loop, and inside of loop, jumped around a little too much there. Inside of loop, I'm just going to say window.request animation frame, and I'm going to call the loop function. So it literally will call itself to the tune of request animation frame, whether that's 60 frames per second or 30 frames per second, depending on what device you're on. This function is going to execute about 30 to 60 frames per second. So then I'm going to call the loop function, and we should have a game loop going. And to show you guys that, what I'm going to do is I'm going to say console.log running. And when I refresh my browser over here, I can go into the console, and you'll see that it just continuously prints running to the console. And that's because this loop function is running on every frame handed back by request animation frame. Just get rid of that real quick, refresh, get things back to normal. Now what I'm going to do is I'm going to actually resize the canvas width and height to fit the inner dimension of the screen. So I'm just going to say context.canvas.width equals document.document element.client width. And that's going to resize the width of my canvas to equal the inner dimension of the window. I'm also going to do the height, so context.canvas.height equals document.document element.client height. So that right there is going to resize that. I'm going to bring in my drawing code here into the loop function. And by the way, resizing the canvas's width or height will erase the entire canvas and reset the array of bits in there, so it'll be a clean canvas every time. So now I have my green square the appropriate size, and even though the canvas still fills up the entire screen, no matter what size it is, if I resize the canvas, it will resize. As you can see, the height is 234. When I resize the screen again, it resizes to 282 or whatever arbitrary number it resizes to. And this green square is now remaining the same size because the canvas is no longer skewing. It's actually resizing properly to fill the entire window the way it should. All right, so now that we have a canvas resizing, we have our game loop updating on every frame, I'm going to create a class called ball. So I'm going to say constant ball equals function. I'm going to have an x, y, radius. So x, y, and radius are going to be the parameters for the ball class. X is just going to be, this dot x is going to be the center x position. This dot y is going to be the center y position of the ball. And then I'm also going to have this dot radius equals radius. And I'm also going to have a color. For now, the color is just going to be red. So I'm going to say the color for red. All right. So now I have a ball, and what I'm going to do is I'm going to come into my, well, I was going to go into the game loop, but I'm not. I'm just going to define a ball out here. Ball equals new ball. I'm going to say 100, 100, and 50. So the ball is going to have a diameter of 100 pixels. I'm going to save, and then I'm going to come back in here, and I'm going to draw that ball by saying, let's see here, context.fill style equals ball.color, which was red, context.begin path, context.arc, and I'm going to hand in the center x position of the ball, which is ball.x, center y, ball.y, the radius, so ball.radius. Then I'm going to hand in the start position to start drawing the circle, because how this works is it literally draws a big arc in a complete 360-degree circle. So I'm going to start drawing that circle at 0 radians, and I'm going to go all the way to math.pi times 2 radians, which math.pi times 2 is an entire circle. It would be equivalent to 360 degrees. So that's going to draw my circle, and then I'm going to say context.fill, and that's going to fill the ball with the ball's color right there, or the context fill style. So now when I come over here and refresh, I'm going to have a big red ball on the screen, and that is excellent. Okay, so now what I want to do is actually get this ball moving around the screen. So the ball is going to have a function to update its position. So I'm going to come in and define a prototype for the ball with that function inside of it. So I'm going to say ball.prototype equals an object literal, and we're going to come into the prototype and we're going to say update position is a function, and it's going to update the position of our ball. But before I can update the position, actually let me just do a simple position update. I'm going to say this.x plus plus. So this is just going to add 1 to the ball's x position every time update position is called, and we're going to call that function on every frame of animation. So ball.update position, and what's going to happen is the ball is going to start to move right on the screen. So now our ball is moving to the right, but we want something a little bit fancier than that, and of course we're going to add collision detection in as well. So I'm going to have to add some variables here to get this thing running the way I want it. So this dot direction equals, I'm going to just give it a random value, math.random times math.pi times 2. So what that's going to do is it's going to set the direction in a random direction over 360 degrees. So my ball is going to start out moving in a random direction 360 degrees around him. So he can move in any direction, basically. I'm also going to have speed, but I'm not going to add that yet. What I'm going to do is I'm going to come in here and I'm going to show you how to actually use a direction to update the position. I'm just going to say this.x plus equals math.cosine this.direction, and this.y plus equals math.sine this.direction. So basically what's happening here is we're taking the polar coordinates, or the rotational coordinates of the ball's direction, and we're converting them to a Cartesian coordinate system where x and y are independent of each other on different axes. So now when I refresh my browser, I'm going to have the ball randomly just choosing a direction and moving in that direction at a constant speed. So this is actually great because we can define a speed variable, and I'm actually going to make my ball a little bit smaller, and that color is terrible. So let's go for 25 pixel radius, and before we do anything else, let's give the ball just a random color. So what I'm going to do, what's great about JavaScript is I can just use either hex or I can use RGB or RGBA values. So I'm going to just create a randomized RGB value. So I'm going to do RGB, and I'm going to add in some randomness. So for each color channel, I'm going to put a random value between 0 and 255. So I'm going to say math.floor, and that's going to round down whatever values inside of it. I'm going to say math.random times 256. And that's going to give me a random value between 0 and 255. Because it will never actually reach 256, because math.random returns a number lower than 1. So it will, and math.floor will actually round it down. So you don't have to worry about hitting 256, which would be an invalid value. But basically, I'm just going to take this, I'm going to copy it, I'm going to add 3 different values, and that's going to be my red, my green is what I just put in, the green value, and the blue. So now every time I refresh my screen, the ball is going to have a random color, and I think that's more interesting than just having solid red, so I figured I'd go for that. Not too complicated to do that, but thought that was a cool little feature I'd add in and show you guys. But anyway, now that we have the ball moving in a random direction and we have it with a random color, what we're going to do is we're going to add some speed to the ball. This way it can move faster than that really sluggish pace that's currently going at. So the great thing about using polar coordinates to do movement is you can control the speed very, very easily because you only have one direction value instead of having X and Y separate. So speed, I'm just going to put equal to math.random yet again times 3 plus 1. So this is going to give me a random value between 1 and 4. Oh, but I actually have to use speed, so I'm going to come down here and multiply this by this dot speed. All right, great. And now you can see the ball is moving quite a bit faster because before it was just moving at one pixel per frame, which is kind of slow and kind of boring. Now it has a random color, has a random direction, and it has a randomized speed, which makes things just a lot more interesting to look at when you have the final product in front of you. So now we need some collision detection, and this is where things are going to get a little bit interesting because we're not using Cartesian coordinates to do this. I mean, we kind of are, but we're starting out, our ball's movement values are all polar, and to draw it on the screen, to move it in Cartesian coordinates, we have to convert from polar to Cartesian. So math.cosine and math.sine are going to take care of doing that for us. And we're also going to have to do some conversions inside of the collision detection. So what I want is for the ball to collide with the boundaries of my browser window. So I'm going to have to hand in the width and height of my browser window. So I'm going to say width and height are parameters of the update position function. And down here, I'm going to go ahead and let height equal, I'm just going to copy and paste this. Height's going to equal the document element dot client height, and width is going to equal the document element dot client width. Now allow me to reuse those values because calls to the document are not exactly super efficient. So hand in width and hand in height. And now here, when I reset the canvas width and height, I can just use those values instead. All right, cool. So now I have my width and height set up. I have it passed into my update position function, so I can actually say if this dot x minus this dot radius, so if the left side of the ball is less than 0, so it's off the left side of the screen, I know that I'm going to have to place my ball directly on the left side of the screen. So I'm going to say this dot x equals 0 plus this dot radius, and that's going to place the ball right on the left side of the screen. Of course, 0 plus anything is kind of pointless, but just so you guys saw that there. Now I'm going to refresh, and when the ball hits the left side of the screen, it stops. So I have collision with my wall, but now I need the ball to actually bounce off that side of the wall. And working with polar coordinates, it's a little bit different. It's not as simple as just reversing the x velocity or the y velocity to have a change in direction. You actually have to convert from polar to Cartesian, do the flip on the axis, multiply by -1, and then plug it all back in and get the polar coordinates again and reset direction. So what I'm going to do is I'm going to use math.atan2. So I'm going to say this dot direction equals math.atan2, and that's going to convert my Cartesian coordinates back into polar coordinates. And then I'm going to say for the y value, I'm going to say math.sine this dot direction. For the x value, I'm going to say math.cosine this dot direction. But since I'm hitting the left side of the wall, and if I can get this to hit the left side of the wall again, if I can get the ball to randomly go in that direction, I want it to bounce back off on the x-axis. So what I have to do is I actually have to reverse the x vector there. So what I'm going to do is math.sine and math.cosine are extracting the x and y vectors or velocities, well, vectors more like, from the direction. And I want to flip the x vector completely around. So what I do is I multiply by -1, and then when I plug these values back into math.atan2, it's going to convert these vector values back into polar coordinates for direction. So now, when my ball hits that wall, it should bounce off in the opposite direction at the appropriate angle, and as you can see, it does. So pretty cool, right? So now I just need to do this for the other 4 walls. So I'm going to say else if this dot x plus this dot radius, and that's going to be the right side of my circle, is greater than width, this dot x equals width minus this dot radius, and then actually it's going to be the same exact line of code to reset direction. So now my ball is going to bounce off the left and right sides, if I can get it to actually collide with that there. Cool thing about this is the canvas resizes, so I can just resize the canvas however I want, and it just expands the world a little bit. So now I'm going to go ahead, I'm going to copy this stuff. This is my x-axis collision code. I'm going to copy it, I'm going to come down here and paste it, and I'm going to change some stuff to make it into the y-axis collision code. So I'm going to say, if this dot y minus this dot radius is less than 0, I'm going to be doing collision with the top of the screen. So I'm going to set y equal to this dot radius, and that's going to set it the distance of the radius away from the ceiling or the top of the screen. And instead of flipping the x vector, I'm going to instead flip the y vector, and I'm going to plug that back into math.atan2 to reset the direction of the ball. So I'm going to do the same thing here. If this dot y plus this dot radius is greater than height, that's going to be the bottom of the screen. Then this dot y, just jumping all over the screen here, equals height minus this dot radius. And I'm going to use the same exact code that I just used for the first y condition and reset the y vector here and just flip it by multiplying by -1. So now my ball should bounce off of all the walls. Let's see, and it bounces off of all the walls. And just a note, you don't really need to have this in there. I tested this without resetting the ball's actual position, and it does work, but just to be safe, you don't want the ball to get caught inside of the wall, especially if you're changing the speed of the ball when it hits the wall. You're going to want to reset your object to be outside of collision every time there's a collision, just to be safe, I think. I mean, that's up to you. You're the designer, but as far as my designs go, I like to completely have my objects exit collision with whatever they're colliding with before I change their direction, if that's what I'm going to be doing, changing direction. So now I want bouncing balls. I don't just want one ball, I want a whole bunch of balls. So I'm going to create an array for my balls. And instead of saying just var ball to have just a ball, I'm going to say var balls equals new array. And I'm going to create a for loop. First, I'm going to delete this ball. I'm going to come in here, create a for loop for let index equals, let's say index is going to be 0, and I want 50 balls, so index is less than 50, index plus plus, and I'm going to create a whole bunch of balls. I'm going to put them into the balls array, not the ball array, the balls array. Balls.push new ball, and I'm going to make the X and Y position first. I'm going to have to get an X position for these balls to start out at. Actually, I guess I can make it random, but I'm going to have them all explode out of the center of the screen, which is going to be pretty cool. So I'm going to say document element dot client width times 0.5. It's going to give me the center of the screen on the x-axis. Let y equal document element dot client height times 0.5, and let's actually fix that typo there so this actually works here and plug that stuff in. New ball, X, Y. Let's make the radius 25 still. That's a pretty good radius. And that's going to create 50 new balls inside of the balls array. Now I'm going to come down here. I'm going to do sort of the same thing. I'm going to loop through the balls array again. And I'm going to update the ball's position and go ahead and draw all of the balls. So let ball equal balls.length. Nope, that doesn't make any sense. Let ball equal balls index. There we go. And I'm going to actually have to set a value for balls here. Index is less than balls dot length minus 1. Let ball equal balls index. And I'm going to come in here and I'm going to draw the ball. So I'm going to cut this code out from here. I'm going to paste it inside the loop. This way we draw every single ball, not just one. And I'm going to have to move this up above that for loop. This way we don't clear our canvas after we draw all of our balls. And I'm going to move the ball.update position inside, but first I'm going to save and see what happens here. Ah, there we go. Look at that explosion of different colored balls, and they're all bouncing off the sides of the screen. I can resize my canvas, and I don't get any flicker because I'm not using resize. I'm actually drawing on every frame, resizing inside a request animation frame, so everything's super smooth. The canvas resizes, and I have a whole bunch of balls just bouncing around. So pretty cool stuff. I don't know if I want to do anything else with this example. I might make the balls a random size. Let's make the balls a random size and see how that looks. I don't know if I'm going to like the way that looks or not, but let's give it a shot here. Random size, let's do math.random times 20 plus 10. Actually, times 10 plus 20 for a base size of 20. I'm going to put that all inside of a math.floor. Now we have a bunch of different size balls bouncing around the screen, and you can see that the collision works just the same. Doesn't really matter what their size is. Everything works pretty well. They have randomized speed, randomized color, randomized size, and I think it looks pretty cool when they all start from the same position right there. I mean, that's pretty neat. So that is how to make a bouncing ball example using polar coordinates instead of Cartesian coordinates. So I hope you guys enjoyed this, and I'll see you next time.